This SOS video is about an arithmetic sequence that can be graphed using a discrete graph. So as a reminder, arithmetic sequence is a list of numbers that are created by adding the same number to each previous term. A discrete graph is a graph where the points are not connected because you can't have a fraction of a value. Okay, so to graph an arithmetic sequence, you label the axes. You might want to use, instead of our traditional x and y, other variables such as n and a sub n that shows the input and the output. Then you plot each ordered pair. Remember, n is our input, usually shows your place value, first place, second place, and a sub n is the value. What number is actually in first place, in second place? Do not connect the dots. You can't have a fraction of a place. There's no place that's between first and second place. And you can include a title if necessary for your graph. Remember, your position number, the place number, is n. We know that as our x value. And the output value is a sub n, or our y value. So let's take a look at the first graph. You're asked to graph the following and write its explicit rule. So the arithmetic sequence, -4, -1, 2, 5, and 8. Okay, so to graph that, I do need to know what the input and the output is. If you wanted to write, let's see, they have n and a sub n here. So I'm going to make a table of values. And my first term was -4. My second term is -1. My third term is 2, and so on. Fourth term is 5. The fifth term is 8. And I graph it simply as this with my ordered pair. Remember, our n is our x value and our a sub n is our y value. So I have 1, -4, 2, -1, 3, 2, 4, 5, be up here, and 5, 8. And you can see it follows a linear pattern, as discussed in a previous SOS video. We do not connect the dots because, as I said, you can't have a position in between 1 and 2. You have first place, second place, third place, and so on. And these are the actual numbers. There's no numbers in between with this in our sequence. Okay, remember, to write our explicit rule, we need two things. We need our first term, and we need our common difference. So our first term was -4. Our common difference is, what does it take to go from -4 to -1, -1 to 2, 2 to 5, and so on. And you can see pretty clearly from here, our common difference would be 3. If you weren't sure, take any term, say for example 8, and subtract the previous term, 5. And I would get 3. Well, what if I took -1 and I subtracted the previous term? Remember, subtracting a negative is the same as adding a positive, and this would also get me 3. So I know my common difference is 3. I write my equation. It's a sub n is my first term, -4, plus my common difference times n minus 1. Now, a great way to check to make sure that the equation you wrote is correct is to put that in your calculator. Obviously, with your calculator, instead of n, we're going to put x. Okay, so let's turn this on. I go to y equals. I get rid of what's there. And I'm going to type in -4 plus 3 parentheses x minus 1. What's really important is I want to make sure that when I have this function rule and I look at my table of values, it will match the table of values we have here. So to get that, remember, we have to press second graph to get our table of values. And take a look. When x is 1, y is -4. Exactly what we have here. When x is 2, y is -1. Anytime you write your equation, you want to make sure that it matches the table of values you had. We could write our equation here if we wanted to on the discrete graph. It's going to be up to you and also what your teacher is requesting. But this is showing this is the pattern for here. And here's an example that's a real life example. A photographer charges $10 for an appointment and $5 per print. Graph this sequence. Okay, if I'm going to graph a real life application, I need to know what my axes stand for. So our first thing is how many prints we have. So our x-axis or our n-axis is saying number of prints. And our y-axis, or in this case, we would say a sub n, with this arrow here, is going to be the cost in dollars. Okay, so when you show up for your appointment, you have purchased no prints, but it's going to be $10 immediately. If you purchase one print, you've already paid the $10 for the appointment, and another $5 would give you $15 total. If I have two prints, well, $10 for the appointment and 2 times 5, another 10, so that's going to be 20, and so on. Every time I purchase one more print, it's going to be another $5. And you can see as we go along with this that this is a linear function, which we know an arithmetic sequence is. So you graph the sequence. If I ask you to write an explicit rule for this, remember we need our first term and we need our common difference. So our first term is not our initial one. Our first term is how much was it when we purchased one print. So that would be 15. And our common difference is going to be the $5 per print. So our rule, a sub n, is my first term plus my common difference times n minus 1. Remember when we simplified it in the other video? If I simplify this, I have a sub n equals 15 plus 5n minus 5. A sub n, 15 minus 5 is 10, 10 plus 5n. And that would make sense looking at our graph because our 10 is our y-intercept, our initial amount, which is shown like this on the graph. Okay, and that's the SOS video on how we graph an arithmetic sequence, which ends up being a discrete graph. We do not connect the dots.